All right, looks like we got Algebra 2, Lecture 131 through 2-3, OASA 2A12. The student will solve exponential equations. That's an equation that has a variable in the exponent, and we're going to use logarithms to solve them. So here we go. We talked about logarithms in the past, and I want to talk about the power property of logarithms and how we use that to solve exponential equations. The power property of logarithms says that if you have the log, you're taking the log of something, and that thing that you're taking the log of is being raised to some power, in this case it's m, we can rewrite this logarithm by moving the power from where it was to a position of a coefficient. It gets physically larger when you do that, and these two expressions have the same value. That's the power property. We can take this power and make it a coefficient. Logarithms are the only thing you can do that in that I'm aware of. So there we go. We're going to use that little factoid. And see if I can get this out of the road. There we go. Solve and round to the nearest 10,000. So I've got to get a calculator handy, and I think I've got some keys over here. See if I can get them right or wrong. Here we go. I'm going to try to solve these puppies. First thing I want to do when I'm solving is get this part right here that has the variable in it. That variable is in the exponent, so it's an exponential equation. I want to isolate this part, so I'm going to add 5 to both sides. That will yield 12 to the n minus 1 is equal to 20. So I've isolated the part that has the variable in the exponent. Now I'm going to take the log of both sides. So I just write the word log. You guys may remember that. To take the log of something, you just write the word log next to it. We can do anything we want to an equation as long as we do it to both sides, and I'm just taking the log of both sides. Now I'm going to use the power property. I'm going to take the exponent and move it to a position of the coefficient. And that's what I'm going to do right here. I'm going to take this n minus 1, I'm going to move it right here. Now I've got to make sure when I do that I put it in parentheses, because it's going to be n minus 1. The entire thing will be multiplied by log 12. So I'm going to take this and move it right here. Here we go. N minus 1 log 12 is equal to log 20. Okay, now I'm trying to get n by itself. Now it's no longer in the exponent, so this isn't a horrible looking equation anymore. All I have to do is divide both sides by log 12. That'll get n minus 1 by itself. Then add 1 to both sides. So I'm almost finished solving this equation. And then we'll round it to the nearest, I think, to 10,000. That's the 4th decimal place. I'm going to divide both sides by log 20. Or log 12, I'm sorry. That will cancel. It'll be log 12 in the denominator over here. So I have n minus 1 is equal to log 20 over log 12. The last thing I want to do is add 1 to both sides. I'm trying to isolate n. So here we go. N is equal to log 20. Whoops, I don't know where that came from. Let's see if I can get rid of it. Nope. Probably is not going to let me get rid of it, I don't think, unfortunately. So I'll just keep working. We'll pretend like that didn't happen. That's log 20. My board is brand new and it's just giving me fits. Log 20 over log 12. And I added 1 to this side of the equation, so I got to add 1 over here. And we just enter this into our calculator. Go log 20 divided by log 12 plus, and hit equals, and then say plus 1. And let's see what we get. I'm gonna try to move this one more time. See if I can get it to move. It probably won't. Nope, it won't. Here we go. Where's my calculator? I'm hitting log 20. Log 20 divided by log 12 equals, and then I add 1 plus 1 equals, and I want to round that to the nearest 10,000th. I believe that's what the instructions said. Let's take a look here. Yep, so that's the 4th decimal place. And that will give me whatever it gives me. Where's my calculator? I had a calculator here just a second ago. This morning is not my morning. Good Lord. Well, I've got the key. I'll just write the answer. Oh, here's my calculator. Okay. Log 20 divided by log 12 equals plus 1. 2.20557. So rounding that to the nearest 10,000th will be n equals 2.2056. Okay? And let's see what the answer key says. The answer key says 2.2056. So that means if n is 2.2056, I'm plugging in right here, raise 12 to that power, subtract 5, I'll get 15, or very, very close because we rounded it to the nearest 10,000. All right, let's do another one here. I'm going to isolate this term right here by subtracting 5 from both sides. This will give me 2 to the x plus 9 is equal to 67. I'm going to take the log of both sides just by writing the word log. Whoops, brain damaged old man. Log of 2, dagnabbit, having a rough morning. Log of 2 to the x plus 9 is equal to log 67. There we go. Now we're going to take this and use the power property of logarithms and move it to right here. X plus 9 times the log of 2. We employed the power property is equal to the log of 67. Or, no, I'm sorry. Yes, that's right. Log of 67. Now, I want to get x by itself, so I'm going to divide both sides by log 2 and then subtract 9. That's the plan. So if I divide this side by log 2, I'll wind up with x plus 9. If I divide this side by log 2, I get log 67 over log 2. Scroll a little bit, if my board will allow me to scroll, which it will. Okay. Okay, so now all I have to do is subtract 9. And if I subtract 9 from both sides, I'll wind up with x equals log 67 over log 2. I subtracted 9 from this side and got x, so I have to subtract 9 from this side just to stay in balance. And I put that into my calculator. I'm going to hit log 67 divided by log 2 equals minus 9 equals. That's what I'm going to do. There's more than one way to get it in the calculator, but that's what I'm going to do. Say log 67 divided by log 2 equals minus 9 equals, and x will be approximately negative 2.9339 if I haven't made a mistake. And I hope I haven't. Negative 2.9339, yay! So hopefully that's making sense. We're finding variables that are in the exponent by using the power property of logarithms, okay? Our variable is in the exponent. We isolated the term that had the variable in the exponent, took the log of both sides, employed the power property, and then just did some basic algebra 1 to isolate x. got the same thing going on here. I'm going to try to solve this, solve it for v, so I'm going to subtract 4, take the log of both sides, and then use the power property. So I'm subtracting 4. What is that, 11.5 if I subtract 4 from both sides? Now I'm going to take the log of both sides. You just write the word log. Now I'm going to use the power property. I'm going to take this power, the exponent that's in exponential position, and move it to a position of a coefficient. So that will be the quantity, v minus 1, log 3, equals log 11.5. Now I've got two things I want to do. I want to divide both sides by log 3. That'll get rid of that, and then add 1 to both sides, and we'll be done, except for rounding it to the nearest 10,000. So I'm going to divide both sides by log 3. That will leave me with v minus 1 all by itself. On this side, I don't need the parentheses anymore, once it's all by itself. Over on this side, it'll yield log 11.5 divided by log 3. I've just divided both sides of this equation by log 3. Now all I have to do is add 1. V is equal to log 11.5 divided by log 3. And I'm getting rid of a negative 1 by adding 1 to both sides. I added 1 to this side, v is all by itself. I add 1 to this side. Here's my answer, and I'm going to round it to the nearest 10,000th. And that'll be whatever it happens to be. And hopefully I won't mess it up. Log 11.5 divided by log 3 equals plus 1 equals 3.2231. That's approximately. I'm rounding that to the nearest 10,000. 3.2231. Rounding to the nearest 10,000th. That's the 4th decimal place. And let's see if I got it right. 3.2231. Yay! I can't believe it. I haven't made a mistake yet with my arithmetic and equation solving skills. Alright, we got one more. I've got negative 5 to the 5a is equal to negative 77. What I'm going to do is divide both sides by negative 1 first to get this positive and that positive. We'll get rid of, this is like a multiplied negative 1. You can think of it like negative 1 times 5 to the 5a. So I'm going to isolate this by dividing both sides by negative 1, and that will give me 5 to the 5a. Oops. I don't know why that's doing that. Let me see. I'll try going, well, I don't want to start messing around. See if I can do this. Okay. Try to write this back in here. That's 5a. So here we go. Let's see if it's going to let me work it. I'm going to divide both sides by negative 1. Okay. And that gives me 5 to the 5a. Yay, it's going to let me. I don't know what it was doing there. Is equal to positive 77. I'm going to take the log of both sides because I have a variable in my exponent. And when I have a variable in my exponent and I take the log of both sides, I can employ the power property of logarithms and move this from a position of an exponent to a position of a coefficient. 5a log 5 is equal to log 77. Now all I have to do to get a by itself is to divide both sides by 5 and log 5. I'm going to do that at the same time. I'm going to divide both sides by 5 log 5. Oops, I said 5 log 5 and then I didn't write 5 log 5. I'm an old man, don't know how to write a 5 apparently. Okay, and these 5's cancel out. Log 5 cancels out log 5, leaving me with A is equal to log 77 over log 5. You can put this in using your calculator using your fraction button, or you can do it the way I do it. I just go, I'm going to go log 77 divided by, and I'll go parenthesis 5 log 5 close parenthesis, so make sure the whole thing is in the denominator. But there's more than one way to get it into the calculator. As long as you get it in there correctly, that's all that matters. If you have any questions, ask me in class. Here we go. Log 77 divided by, open parentheses, 5 log 5. That makes sure the whole thing gets in the denominator. Close parentheses equals 0.53979. So that's going to be 0.5398 rounded to the nearest 10,000. If I haven't made a mistake. And Lord knows I may have. Let's take a look. 0.5398. Yay! So hopefully that gives you an idea of how to use logarithms, and specifically the power property of logarithms, to solve equations that have variables in the exponent, which we call exponential equations. Okay, so round your answers to the nearest 10,000 exponential equations, you can do this.